Alright, here we are again. And way overloaded on the PC this time. I don't know why, but we'll see what to do about that. And let's get my tools in order here. I don't know how to do that. I don't know how to do that. Bear with me a minute. Yeah. Somehow there is a place, and I can't remember. There's a way to like set up my windows the way that I want them, and I've completely forgotten how to do it. All right. Well, close enough. Close enough. It's going to be a pretty short session today, and the goal is just to print a few things out in the teletype. And then I'm going to pack the teletype up and put it in the back of the truck and drive it to New Jersey for the weekend. So we'll work on that in a little while. Meanwhile, I think it's about yeah, let's see. The thing that I really wanted to do is to get on here and excuse me while I jumble this thing around a little bit. That's about a little bit better, so I can walk past it. Eric F. was asking, like, what's the layout here? And the layout is really cramped, but I'm going to pull the camera out and just show you briefly. My streaming... Whoops. That was no good. That's not what I wanted to happen. My streaming setup is, I'm at the back of one of the areas of the brickyard, and I have a MacBook. And in the MacBook I have a cam link connected to this camcorder, which is a Sony something or other FDR AX33. It's quite a nice little camcorder, but it's small and portable, and it has beautiful kind of stabilization, so I can shake it and it handles it. Then I have a blue snowball microphone that doesn't always respond when I connect it into USB. Then I have a Logitech webcam that's hooked up here to point in vaguely the right direction. That's the thing that you see in the corner in the top. And then this goes on a tripod, and it points down at the machine, and I just zoom it in and out. And then I'm on the Wi-Fi. So that's the streaming setup. Come down to the brickyard in Lynn, and you'll see like the actual layout and stuff, and meet all the other good people who are around here. There's nobody here tonight again. It's kind of quiet, which is fine. So, quick tour of the setup. So in the corner I have a 1970-ish Teletype Model 33 ASR, which means automatic send and receive, which means that it's got a tape reader and a tape punch. In other words, it can send automatically by putting a tape into the tape reader and pressing run. and it can receive automatically and just punch it out on paper or print it on the print roll. But it's a computer terminal, so I've connected it to a computer. The goal today is connect it to the oldest running supercomputer that I know of in the world. And the reason that we're going to do that is because I want to print beautiful fractals, because why not? Why else would you go connect to the most beautiful supercomputer in the world? So let's go try. This is going to take a little bit of figuring out, because my credentials are on my phone somewhere. So I am going to just go search for my credentials. So most of these kind of log into some remote thing. I've set them up on the GitHub, and I'll show you kind of the browser window version of that. Sorry, my browser is super slow because OBS is chewing CPU. But yeah, here in the bin directory, there is a set of little scripts, underscore something or other, that connects to different systems. And pretty much all of them are expect scripts. And hey Uzi, good to see you. For some of the oh no. Oh yeah, chugga bang ting. Yeah, we'll do that. I do have a dot matrixy thing that I've never ever used, and nor has anybody else. It's a mystery, but I'm going to take that to New Jersey and maybe unbox it there. But here, yeah, we're going to do this thing. But let me explain a little bit about these expect scripts. You'll see anything that begins with an underscore here is like a little script that runs expect, which is kind of give me a script for logging in automatically to some remote system. And here's the CDC 6500 computer we're going to connect to, and it expects a prompt saying user number, and then I put in this environment variable, but I didn't set it in the environment, so I have to just go look it up on my phone. And so I'm not going to use this script. I'm just going to SSH like manually from the terminal, from this terminal, to connect to the CDC 6500. So let's try that and see. So how about a little bit more focusing on the thing here. Bear with me while I mess around with cameras a little. And straighten that back. And aim this in the right general direction. And zoom a little bit so that you can actually see the text of it as it appears. So yeah, here's the teletype. And I want to SSH from the machine I'm on right now. Because that's the Google Coral thing that I'm actually logged into. But I'm going to SSH into CDC 500 at and it's looking promising. Okay. Chinese food and tried to sit down and get some work done. yeah, I know the feeling. It's funny, you gotta like get in the right zone to get work done. If you're anything like me. I find that green tea, and I kind of alternate between sencha and oolong, the iron goddess. So this is the Living Computer Museum's 6500 CDC machine running NOS 1.3, the operating system. Oh, grey's not bad. I like the flavour of it. It's nice and flavoursome. Tea. Nothing better, but please no milk in it. So this is up with 64K of memory and 1 CPU. What happened to the other one? This is a dual processor machine. It's a... Oh, CPU1 died again. Oh no. So this machine is a dinosaur, I think, by anybody's standards. It dates from the very late 60s, and it sat at Purdue University for quite a long time. Alright, we're connecting. Let me get my credentials. So this is why we need an expect script, because it times out just printing the login message. So I can use the expect script to like get all the way there without logging it, and then when it sees like user number, then I can turn it interactive again. I think that's probably the easiest thing to do. But to do that, I'm going to go cheat. I'm going to connect in this thing here, and I'm already on the host. So and there we are. So log user 1 and expect. I've been playing around with this and I haven't really tested it to get a final version. Call them up and tell them they need to support 110 baud connections. Yeah. The people that run this have incredible stories to tell. It's really amazing. So is user number the thing that I should wait for here? It may be, but let's look back at the printout. It says Living Computers Museums plus Labs 6500 user number. I think I'll wait for user number, and then I'll get the prompt. And then I'll go, if I can remember how to switch editors here, I'm just going to say interact, and so here I'm just going to say interact. So as soon as I see user number, I'm going to get this kind of multiple thing prompt, and let's try it. The CDC 6500. So it has 64K of core memory, and they have another 64K that doesn't really work very well. And it has 2 CPUs, and it dates from the 60s, the late 60s, and it was designed by Seymour Cray. And it's one of the first Cray supercomputers, but of course before it was Cray Corp. It was part of CDC. It's water cooled. It's built of transistors. There's no integrated circuits because it predates all of that. And the transistors are in this thing called cordwood units. And if you have a web browser handy and go browse for CD6500 cordwood, then you'll get all sorts of interesting pictures and stories of this machine, and and what it looks like. There's things like, these are the processing blocks that it's built with, and then there are whole enormous frames where they all sit together, and as I say, it's water cooled. They've had some interesting things with the coolant flaking out, and then the console monitors are these amazing like dual screen monitors, but these are just the consoles. It's an incredible story. They rescued it from Purdue, or they had it donated from Purdue, where it had been decommissioned, obviously, and painstakingly fixed it up and got it working again. So let's see if we can connect. Yeah, there's nothing great about this. It's not... Didn't design any seating. I don't know, I think the seating has probably been lost to history. Yeah, okay, we're not having great success here. For some reason, my expect script is not hiding all my login. I don't know why would that be? Well, let's see. Let's see if it times out again, and we'll just come back to it if it doesn't. Yeah. I think it may time out again. This is my guess. But my machine that I'm running on here is having all sorts of little overloady problems, so I can't like get into the text editor. You used to see all these pictures of crazy computers with chassis designs with seating. Yes, indeed. Absolutely. These little columns around with what looks like seating around it, but the seating is actually that's where the coolant that's where the coolers are. All right, let's see if I can log in or if I time out again. And if I time out again, then we'll just fix my thing. Nope, timed out. Okay. Well. Okay. The junk after user number is deliberate. It's deliberate to overwrite so that when you actually type your password or your user number, then it doesn't come out in the paper, which is very thoughtful for people with hard copy terminals. It's like, that's exactly what I want. So, yeah. Let's go ahead. Yeah, my editor still has this glitch. Oh yeah, I don't know. I don't know if they can turn echo off or not. So my ed still has this glitch of like not really doing things right. But let's deal with that. I want to go just before interact. I want to say log user 1. And yeah, maybe it's just expecting. Oh. Okay, try it. Yes! We are connected! We are connected! Alright. Recover/system. I don't know what this means. Ooh. Oh, that's interesting. Okay, so I'm in the right place. So there's not really a shell. No, it didn't. There isn't kind of a shell. Instead, you go into like a subsystem, and the subsystem I'm going to go into is basic, and I'm going to get an old file. And sure enough, it gave me an old file. So I went on with SSH earlier yesterday and actually entered this Mandelbrot set program, which is basically it's a basic program to go calculate and print a fractal in the series of other fractal programs that I've been working on that we showed last time with the HP 2000 and etc. So these are all there are copies of them up on the GitHub here. So Mandelbrot CDC is the one that we've got here. I'm going to see if I can remember how to list it. Yeah, we're in the basic subsystem, and there's a Fortran subsystem, and there's an access subsystem, which is for talking to other users, and so each of these subsystems is kind of like, you know, on the HP 2000 where you log into the machine and you've just got like basic. That's what you're in. It's kind of like that. It actually has a more powerful file system and a real interesting kind of file system. And it has multi-user stuff, and of course it's an interactive computer. Oh yeah. Oh, believe me. Yeah, you can get through 10,000 lines pretty easily. Yeah. Now I want to change the coordinates here. While this is printing, actually I'll let it print because it's a beautiful little program. You start off saying, what's the real and imaginary coordinate at the center of the plot? And D on line 220, D is the diameter of the plot, essentially. And then from there it calculates, like, how am I going to iterate across all the rows and columns? And also I upped the number of iterations before it decides whether it's converging or not. We're dropping a lot of frames on the stream, I'm afraid. Sorry, this is glitchy. Yeah, you have to renumber sometimes. There's actually there's a renumber command in here, conveniently. Yeah. Yeah, I mean, BASIC is slightly clumsy. But this thing of kind of numbering the lines is an interesting shortcut, because this concept that we have in, like, Unix... Oh yeah, it does. In fact, this BASIC has amazing stuff. I don't have the quick reference card handy, but the BASIC that's on this machine... there's a few things, actually, about this. Let's put that up there. If you look in lines like 480 and so on at the end, it doesn't have a mod operator. So you can't say... so I've got this kind of list of characters, and I want to say if I've gone past the end of the list of characters in line 480, then... if it's short on the string, then go print it. Otherwise, subtract length of the string and then loop on line 490, 500. That's like my little mod routine. But instead, it doesn't have, like, simple, obvious things that you'd expect, like mod. But instead, it has a whole ton of matrix functions, because this is a supercomputer. Like, it's designed for building numerical simulations, right? So it has really good matrix functions built in, which is kind of cool. So I want to edit the coordinates. Let me show you where I'm going to put these coordinates. On the browser, I've been playing around with this thing called the web Mandelbrot, because it's really kind of nice. And with this, you can, like, click to go zoom in. And if you click a place, it'll zoom to it, and it'll go recalculate. And you can see kind of my machine is a little slow right now because of all the other stuff that's running on it. But if I click there to zoom in, and then click, like, maybe here to zoom in, I think this is about what I want to plot. And then the convenient thing of this is I can see my numbers. I can see the coordinates up at the top. So if I read out those coordinates and write them into this BASIC program, we should get this plot. Yeah, I'm also, yeah. So, back on the line listing, line 200. My real coordinate is negative 0.551. My imaginary portion is 0.6265. Equals D equals 0.125. Let's try that. And line 210 broke. So the save command works kind of, yeah, it's 0.6265. The save command works weirdly. Instead, there's a replace command that says right over the one you've got. Save means like save as, if it's new or something. So let's try run it. And it may work or it may not. So we're running a Mandelbrot basic app on a mainframe with core memory, and it's made of transistors, and it's in Seattle at the Living Computer Museum. And I think my coordinate, my imaginary coordinate is upside down. And you can see the timestamp, it says 990501. I assume that there are things in the system that just won't handle the 21st century. But I think this qualifies as supercomputing, 60s style. It's rendering a Mandelbrot set. In ASCII, on a completely age-appropriate machine. I mean, the Teletype terminal is exactly the same. It's exactly the same vintage as the supercomputer itself. It's a late 60s terminal, and so this type of terminal was originally connected to this actual machine, but over a direct line instead of over several stages of internet. And it blows my mind that this thing is... Yeah, so CRTs... So you saw the pictures on the web there of the console of the CDC, and it has these kind of dual CRT displays. CRTs were around in the 50s, and the first ones were built for radar and so on. But they were crazy expensive, so it's not really about is the technology capable, it's more about is it affordable. And by about 72, CRTs were affordable. I don't know the date for the VT50 and the first DEC CRT terminals, but it was early 70s. And then by the late 70s, these teletypes were completely obsolete because the CRT had got cheap enough. Yeah. And then there are things like there's a Tektronix Vectorscope terminal, which is like a graphics terminal with a CRT. And that's surprisingly old too. I think maybe at the late 70s. Maybe, yeah, certainly the 70s and not into the 80s. But the Teletype is really special because it was universal, kind of, it was cheap enough that everybody could buy one. Everybody who had a computer could buy some terminals for it. And also because of its relationship with Unix, which is that this is basically the machine that Unix was written on. This is the terminal, this is the standard I/O. So yeah. So this is a portion of a Mandelbrot set. And it doesn't look super fractally, but I think it's quite nice. Oh yeah, Unix is cursed because it has to be, yeah. So ASCII Mandelbrot set from the CDC 6500. So if anybody watching this is coming down to the VCF East in New Jersey, one of the Living Computer Museum people is going to be there, and they will be talking about some of their machines. I think they have some IBM machines and the CDC and a bunch of others. Does it use ASCII? Well, there's a good question. So yeah, basically this uses ASCII. As you can see, like it says run complete, and that is actual ASCII. It's 7-bit ASCII. But the CDC is not an 8-bit machine, so it's not like you have bytes that are ASCII in memory. Instead, they have a 60-bit word, so a one word of memory could store a whole bunch of bits. Like it could store 10 characters if you squished them together. So I don't know actually how the ASCII text is encoded in the words. 60-bit, absolutely. But if you're going to do, like, if you're going to build a supercomputer and you want to be able to get through instructions a lot of the time, then build it parallel, right? Build a wide instruction bus, build a wide memory bus, like do things in parallel. And even in the 60s, that was a good strategy. Yeah, so I'm going to edit this again, and I'm going to edit lines, the same lines, and I'm going to reset it to like the default Mandelbrot set picture by going let's see if I get these. Yeah, you can actually. You can totally modify the program to prompt. Absolutely, and it has input and input dollar and those traditional basic commands. There is a. I want to find the quick reference card. And I don't know where to find it anymore. But let me see if I can find it. Yeah, and BASIC was kind of the first language that I learned to write in programs on a computer, and so I have a distinct attachment to it. But likewise, I haven't used BASIC for many years, and suddenly it all comes rushing back. So yeah, this is a real mainframe computer. I'm trying to find the basic interpreter thing. Anyway, I can't find it. Computers. Here's the Living Computer Museum like homepage, and they have all sorts of fun machines. And then down the bottom here somewhere is the CDC, the third supercomputer in the series, designed by Seymour Cray. And I don't think I have like a link to more. There's a survival guide, which is the thing I'm looking for. But anyway, I'll find it. Yeah, and BASIC is a little easy to learn. I don't know, it's yeah. But the file system of this CDC machine, here we are, this is a real fractal. The file system of this CDC machine is is organized in a very different way than Unix that we're expected to understand nowadays. There's a primary file that you're looking at, and then there's other permanent files or temporary files. And file names, it's like DOS. You can't have a file called con in DOS because it... But then cat list with some funny other things to show a detailed list. Yeah. So, anyway, ancient history. Of printing a fractal, and the ragged right edge, that's a bug in my code somewhere. I guarantee it. I don't know why, but I think it's dropped some characters somewhere, and I think it's just a bug in my basic. So anyway, let's see. Let's look at the catalog of files. And I have just one file. It's called Mandel. And there we are. Well, I'm going to sign off now because my next task is to unplug everything and lift it and put it in the back of my car so that I can carry it to New Jersey. And if you're going to be there, then I'll see you there. But here we are, connected to a mainframe. I guess I should log off. I used 14.5 units of computer time back in the day when you had to account for computer time and you'd actually get billed for it. So there we are, living computer museum to a living mainframe from the 60s. I'm going to sign off now. Come by at the VCF East if you're around. Come say hi. I am totally looking forward to that, and maybe we'll stream from there at the weekend. And yeah, see you next time. Thanks everyone.